All right, welcome to the Explainer. Today we are going to tackle something you use literally every single day, probably without even realizing it. We're talking about probability. It's really just the science of uncertainty. And I have a feeling that by the end of this, you're not just going to understand it. You're going to realize you've been a pro at this all along. So let me just ask you straight up. Do you think you know anything about probability? What's your honest gut reaction answer to that?
If you immediately thought, nope, not a thing, you are definitely not alone. That's what most people say. But here's the kicker, and this comes right from our source material. That no is almost never the real answer. The truth is, you're probably a natural. Think about it. Every time you check the weather and think, it'll probably rain, I should grab an umbrella. Or when you decide to leave for work a little early because there's a good chance of traffic, well, that's you making a decision based on probability. You're weighing the odds completely intuitively. Okay, so to see how we can go from that gut feeling, that probably, to something a bit more solid, let's dive into this great real-world problem from our source. Let's call it Sunil's dilemma. So meet Sunil. He's a student, he's got a newspaper route. Now, he's got his regular customers, sure, but there are also these 10 other people who might buy a paper from him on any given day. So his problem is, how many extra papers should he carry? If he brings too few, he misses out on sales. But if he brings too many, he actually starts losing money. It's a classic case of trying to manage the unknown. And here are the stakes, plain and simple. Every extra paper he actually sells, boom, he makes 30 paisa. That's a win. But for every single paper he carries around that goes unsold, he loses 10 paisa. So this isn't just some wild guess he's making in the morning. It's a daily calculation of risk versus reward. So to really wrap our heads around Sunil's problem and help him out, we first need to get on the same page. We need to learn the language of chance. It gives us a way to take a messy real-world situation and give it some structure we can actually work with. First up is this idea of a random experiment. Now, that just sounds fancy. All it means is any action where you can't predict the outcome for sure. Tossing a coin is the classic textbook example, right? Heads or tails, who knows? But for Sunil, his random experiment is way more practical. It's seeing how many of those 10 irregular customers actually buy a paper each day. Okay, so if the experiment is the thing you do, the sample space is the list of every single possible thing that could happen. Think of it like a map of the entire universe of outcomes for that one experiment. Let's make that a little more concrete. Say our experiment is just tossing a coin 3 times in a row. Well, this right here is the entire sample space. You can get 3 heads, you can get 3 tails, or any of the combinations in between. There are exactly 8 possible outcomes. That's it. This is the whole list. Now, usually, we don't care about that entire universe of possibilities. We're interested in one specific thing happening. That's what we call an event. An event is just the particular slice of the sample space that we're watching for. So using our coin toss example, an event we might care about is getting exactly 2 heads. And check this out. This visual is a fantastic way to picture it. The big box, that's your sample space. Everything that could possibly happen. The circles inside, those are your events, the specific things you're interested in. And you can even see how they can overlap. That little area in the middle, that represents outcomes that are part of both Event E and Event F.
Okay, so we've got the language down. We know the key terms. Now for the main event. How do we go from just talking about chance to actually putting a number on it? How do you calculate probability?
Well, the most basic way to think about it is this idea of relative frequency. Imagine you flip a coin. Now, if you only flip it 10 times, you might get something weird, like 7 heads. But if you were to sit there and flip it 10,000 times, you'd notice something amazing. The ratio of heads would get closer and closer and closer to 50%. That stable number that shows up over the long haul, that, my friends, is probability. Now, here's the really cool part. For a lot of simple cases where every outcome has an equal shot of happening, like a fair coin or a standard die, we don't have to do thousands of trials. We get to use a beautiful, simple formula. The probability of an event is just the number of outcomes you want divided by the total number of outcomes possible. That's it. Let's put that formula to the test right now with a super quick example. You've got a normal 6-sided die. You roll it. What's the probability that it lands on an odd number? Okay, let's just break it down using the terms we just learned. The sample space, all the possible things that can happen, is the numbers 1, 2, 3, 4, 5, and 6.
So there are 6 total outcomes. The event we care about, getting an odd number, well, that happens if we roll a 1, a 3, or a 5. So there are 3 favorable outcomes. Now we just plug it in. 3 favorable outcomes divided by 6 total outcomes gives us 3 over 6, which is 1/2, or 0.5. Simple as that.
So let's just take a step back and look at the big picture here. We started with just a vague, intuitive feeling of chance, and now we have this whole structured way of thinking about and actually measuring uncertainty. That is a really powerful shift in thinking.
And let's bring it all back to Sunil. See, now we have the perfect framework to understand his problem. We can't solve it for him without any data, of course, but we know how he could solve it. He'd need to track his sales over time, that's his experiment, and then he could calculate the probability of selling 0 extra papers, 1, 2, and so on. And with that data, he could figure out the sweet spot for maximum profit. So, what are the big takeaways from all of this? First, probability isn't some scary abstract math concept, it's just a precise tool we use to measure how uncertain something is. Second, you are already using it all the time, just on instinct. Third, all those new words, experiment, sample space, event, they're just there to give that instinct some structure. And finally, as we saw with the die, the actual math can be incredibly straightforward.
Which really just leaves us with one final thought to chew on. Now that you have this framework, just think about your own day. How many of the little choices you make, the little gambles and calculated risks, from hitting the snooze button one more time to picking which lane to drive in, are really just probability problems in disguise? Thanks for joining us.